Alright, hell yeah. So we're learning linear algebra. And this is the book that I'm doing. And I've been spending about 3 hours a day on this thing. We're doing it crispy style. And I'm almost at page 450. So anyway, so today's video is going to go over how they do an inverse matrix from, you know what I mean, the way that we should be doing them. Because it's fast, it's easy. But with fast and easy, we lose all touch of reality of what's going on. So we're going to do fast and easy, and then we're going to do it for real. So this is the first way that we're going to do it. You have to know about a determinant, an adjoint, which is the transpose of a cofactor. See, all this just craziness. You know what I mean? No one knows what any of those terms are. I barely do either. But all said and done, you do simple things to get this answer the fastest. And then what we're going to do is we're going to say, hey, you can set this up. It's just going to be, we need to solve for these 9 values. That's just 9 values, 9 equations. You know, 9 equations, 9 unknowns. Let's do it. So that's what we're going to do. Hell yeah. And we don't have to drag, you know what I mean? So the inverse matrix from the easy style, let's see if I can remember that equation. Inverse matrix is going to be 1 over the determinant of A. So we're going to have to figure out what the determinant of this is. The simplistic aspect of, if I just have a 2 by 2, determinant is just 1 times 9. You can do that. Minus, you know what I mean? Don't forget the minus, but minus 3 times negative 1. Hell yeah. And that would be 1 times 9 is 9. Minus 3 times negative 1 is negative 3, so minus a negative 3 is an addition, so it'd be 12. You know what I mean? So hell yeah. So keep that in mind because that'll be a part of finding the determinant of A. You know what I mean? Hell yeah. And then we're going to multiply it by the adjoint of A, which is just the cofactor and then transposing that. So and what the hell is the cofactor? Like I said, no one knows, no one cares, but we do care. Once we get this, then we're like, hell yeah, we cared. All right. Let's do the determinant of A first. So they're going to say that the determinant of A, and this is what you should be doing, is making videos on the stuff that you just learned in that day, because the determinant of A, what is it? What is it? It's, yeah, what is it? Oh yeah, because I'm going to get this confused with the cofactor. The determinant, oh yeah, the determinant of A. Yeah, I don't want to mess this up. I don't think I'm going to. Holy Toledo. Let me just guess. I think the determinant of A is this value right there, which I'm just going to call A. And I'm going to say this matrix is in A, B, C, D, E, F, G, H, I. Because there's a million different ways to find the determinant. And I can double check myself right away. So this is good, you know what I mean? I just studied this stuff today. Who knows if we're going to do it? So I'm going to think it's A times the cofactor of A plus B times the cofactor of B. And then plus this value C times the cofactor of C. Now, do I continue on for D, E, F, G, H, I? Hell no. You know what I mean? That's why it's easy, easy, cheesy. All right, the cofactor is just the minor of A. But then with it, it's either going to be a plus or minus. We have to figure that out. Same thing for all the other ones. I could write the same thing again. And then so, you know what I mean? Matrix style, they're going to say, hey, this we're just going to use A for all of them, but this is A, row 1, column 1. This is A, row 1, column 2. That's how you'd write it, row first. Anyway, so A, 1, 3, and this is A, row 2, column 1. Row 2, column 2, 2, 3. A, 3, 1, A, 3, row 3, column 2, row 3, column 3. And they're going to say the cofactor. So if I say the cofactor of AA, so I'm going to do cofactor of A1 is going to be the minor of A1. We're going to get to that in a second. Multiplied, this is kind of interesting, negative 1, and I really have to say this is like this. If I say, well, I can do it like this. Negative 1 to the 1 plus 1. No, and then you can go back and put your i's and j's and just confuse the entire universe. But hell yeah. So this value, any one particular value, could be right over there, is going to be A, row I, column J. And then so we have the minor, so the cofactor of this, Aij, we'll get to what the minor is and the cofactor is in a second. But the minor, so anyway, this cofactor is going to be the minor of Aij. -1 to the I plus j power. And this -1, like -1 to the 1 is just -1. -1 to the 2 is -1, -1. And that's going to be +1. So, spitting everywhere. Anyway, so if this power is a negative number, like 1, I'm going to get a -1 here. If it's going to be a positive number, I plus j is positive, we're going to get a +1. So that's going to change the sign. That's all that does. Cool. Now what the hell is the minor? So the minor of 1, 1, yeah, anyway. The minor of 1, 1 is like, hey, block that row out and block that row out and that column out. That, like, you know what I mean? That does that. And then we're just left with 4. So this strategy only works for a 3x3, but typically you might be working with 3x3s. I've not gotten into the part of the book where I can do this for a 4x4 and so forth. Hell yeah. But now I'm just, and then what the minor is like the, the remaining determinant. So if I take that value and then cross out the row and column, I'm left with a block of 4. And then I can take the determinant of the remaining values. So hell yeah. So, I don't know how you would actually write that with I, J, K, I's and J's, I think you just have to say it what it is. But anyway, so hell yeah. So the minor of A is going to be A22 multiplied by A33, and then subtract we'll do that one, 2, 3 multiplied by A32. So that is going to be, the determinant of those 4 values, matrices values. And then we're going to multiply it by this -1, and we have 1 and 1, so that's just going to be a +1. So hell yeah, we're done. The cofactor of A11 is that. And cool. And then so that would go in to the cofactor right there, and then we would multiply it by A, and that would give us the determinant. I think that's right. So let's just go for it, and let's not drag. So we have A is 1, so we're going to have 1. I'm going to have the cofactor of A. I think the first thing to do is just figure out this I and J part. This is going to be row 1, column 1. This thing is going to be a +1. Let's just ignore it now, or we can say +1, just so we have like that value, the +1 or -1, and now we're going to find the determinant. 9 times 0 is 0, so we have 0 minus 1 times 7. So we have a -7. Hell yeah. And so that is going to be -7. That's that first value, -7. Now we move on to the second value. B is -1. The cofactor of B, row, column. And it's in row 1, column 2. Those are odd, so we're going to have a -1. All right, this is the B value V, B, and then this is the sign change due to the location of that cofactor part. I think I'm saying that right. Cool. And then row and column, and then the determinant of those remaining 4 values. 3 times 0. I'm doing 3 times 0 is 0. And then 0 minus -2 times 7. This is where I mess them up, because -2 times 7 is -14, but it's 0 minus -14. That is 0 plus 14. Ooh, that's tough. All right, so hell yeah. So we have 0 minus 14, which is 0 plus 14 plus 14. Booyah. And I probably already made my first mistake, because if that's -14, I messed up. You know what I mean? So let's no, I didn't. No, this is the cofactor. So the cofactor part, see how this is where I was getting confused. And I already made huge mistakes today. But for the determinant, you're going to take that value multiplied by the cofactor. So the cofactor here is just going to be a negative 14. But then I'm going to multiply that cofactor by this value b to get this, the equation for the determinant. That's a real easy thing to mess up, and sign changes are the beast. Okay, so hell yeah. So we got a positive 14 plus 14. I don't think I'm getting anywhere near 212. We'll see if we messed up. And then I just have to start the video over again. Alright, hell yeah. So C is 5, so we're going to have 5. Its location is row 1, column 3. 1 plus 3 is even, so we're going to have a positive 1. That doesn't change. Alright, now we're going to take the determinant of that, 3. So 3 times 1 is 3. So 3 minus negative 2 times 9 is negative 18. So I'm going to do plus 18. I have a 21 here. There we go. There we jazz it up. So doesn't seem like enough. But we have 5 times 21. 5 times 21 is 104. Hell yeah. Yeah, I didn't think it was going to get there, but because I was thinking this was only, I looked at this and I was like, that's about 50. It's like, no, that's double, because 5 times 10 is 50. 5 times 20 is 100. 5 times 5 is 100. Is that 105? I was going to say this is 104. Why was I going to make that mistake? Anyway, so we have, 10 times 5 is 50. Another 10 times 5 is 100. 1 times 5 is 5. Plus 105. This is going to be 105 plus 7. And look what we have. We have 112. Alright, so we are 1/3, not even a third of this video is going to be done. But hell yeah. We're we at least solved for one thing. We didn't make any mistakes, except we confused the fact that this is the column number. I mean the number in that row and column, B, multiplied by the cofactor, because in a second we're just going to get the cofactors. As you can see, like, whoa, wasn't this negative 7? Well, yeah, this was negative 7 because the column was 1. So the cofactor here was negative 7, and then the multiplication of the column was 1. Here the cofactor was 21, and it was positive, so there's your positive 21 cofactor. That's why this 14 is not the cofactor. Negative 14 is, because we multiplied it by the negative 1. And 105 isn't the cofactor, because we took the cofactor of 21 multiplied by the 5. That was just the equation for the determinant. I think that is the place where I'm going to make the most mistakes, is knowing that the determinant is like, hey, those values multiplied by the cofactor. But yeah, so get this, let's buzz. And this is really good for practice. Like, that was the first time through. That was hitting each piano key. So I think this is a good learning strategy, is to use your calculator, because you can find the determinant. That was just using those values. You can find it using these 3 values. Those 3 values as your kind of ABC. You know, if we write them like this, I can do the DCF. D right there, cofactor D. E right there, cofactor E, F right there, cofactor F. And the wild thing about this, like, I like it. The proofs are so hard to be like, well, why can we do this? I can take these values in this column, and like saying it makes it a little bit maybe more sensical. I have no idea the proof. But anyway, so I can take this as my value, and when I do that, cross that out, and I get those as my determinant, and then with the adjustment for the sign change for the cofactor, times that value, and I can do that. So let's bust. So anyway, so hell yeah, we're going to have 3, and what location is in? Because we're going to, I do the value first, then whether it's positive or negative, and then the minor of that location. Cofactor is the positive or negative times the minor. Hell yeah. So it's row 2, column 1, that's 3. So we're going to do a negative 1. And then if I block this, see, I was already trying to block this and that, you know what I mean? This is the easiest place to mess up. If this is the value, row and column. So those are my remaining numbers. So we have negative 1 times 0 minus 1 times 5. Hell yeah, and we get 15. And, yeah, see, that's why I have this, because today I'm going to make mistakes, and oh, you know what? My bad. So these are cofactor numbers. If I take the cofactor and multiply it by the column, so if I say, hey, and this is the transpose, so that's the other bummer, is that this not only is the cofactors of these locations, it's also transposed. So this is the cofactor matrix, but it's also transposed. So this really isn't that useful mentally. Let me write out the other one. So to transpose this, I'm going to be like, hey, this row goes there, so we have -7, -14, and 21. That's going to be the first row. This one goes there, so we have 5, 10, and 1. And this row goes there, -52, 8, and 12. So, if I thought this was, this value is associated with the cofactor, but I got to divide by 3. If I divide this by 3, I should get that cofactor, because today's video is just to always double check. Just knowing that this stuff is just wrought with mistakes. A lot of sign errors, and just multiplication and addition. I'll even say 2 plus 3 is 6. You know what I mean? I'll do that. I'll confuse addition with multiplication. Alright, and hell yeah, I don't know why I'm patting myself on the back, but this video is just like, hey, today I studied this stuff, tonight I'm making a video. I think that's very important, because it's really going to dial this stuff in. Alright, hell yeah, so that's our first value, 15. I'm going to store that as alpha I. I always like to use these IJKs. It's kind of like the I hat, J hat, K hat. They're variables that don't come up a lot. Excuse me, and then on a calculator, it's really, especially if I'm going to go alpha I plus alpha j plus alpha k in a second, which I am to get this determinant, I really like to store values there. So hell yeah, alpha I is now that 15. Alright, so we're going to do this number times the cofactor, of this location. So we have 9. The sign change of the cofactor, I don't know if that's the cofactor part, but the sign part of the cofactor. This is row 2, column 2. It's even. We're going to do a +1. Hell yeah. Then we're going to take this row out and this column out. I think it would be even useful to have little strips of paper. I mean, if you went that extra mile, check this out. We'll get a freshie. But hell yeah. I mean, it doesn't take too much, but there you go, because we got that middle one. And booyah. So now I can just see, hell yeah. I mean, just anything to make your mind not bleed. Alright, so 1 times 0 minus -2 times 5. Now, I think a calculator is a really brilliant thing. And, even like right now, I could be like, hey, what's the determinant of this? Which is the minor. They're calling this the minor. It's not the determinant of A, because you just removed a row and a column. So it's just it's a determinant of these 4 numbers if they were its own matrices, but we call that the minor. Hell yeah. 1 times 0, I might make the mistake and say that's 1. It's really easy for me to do that. But 1 times 0 is 0. 0 minus -2 times 5. So I'm just going to say that's minus a positive 10. But then backing yourself up with a calculator is good, and then 10 times 9 is 90. So the answer should be 90, and we get 90. I'm going to store that as alpha j. Alright, I thought we were going to cook a little bit faster, but hell yeah, let's do that. So we have 7. Row 2, column 3, that's odd, so we have -1. That's the cofactor part. And I'll still do this. Block out that. Hell yeah, so those are the numbers. And now how can you make a mistake? 1 times 1 minus -2 times -1. But hell yeah, you can make a mistake. Look at all those negatives. Not only do you have 1 times 1 is 1, but now you have a minus -2 times -1. Right off the bat, I'm thinking that is negative, and that's the correct answer. Yeah, so that's good at least. But hell yeah, it'd be really easy to just be like, I think I'm adding. I don't know. Anyway, so 1 minus 2. But I'm not double checking that in my mind. I think it's really difficult. So -2 times -1 is +2. 1 minus 2 is -1. I'm thinking I'm going to have a -1, and I'm going to multiply it by a 7, which is -7. And then the cofactor is a negative. So positive 7. That was a lot going on. And hell yeah, see how I almost missed the cofactor, that sign change part. So doing this mentally, wrought with mistakes. But we're doing pretty good. And then if I wanted to know the actual cofactor of this location, divide by 7. And that's going to be the value of 1. The other one was 90. 90 divided by 9 was 10. So hell yeah. But let's store that as alpha k. Alpha I plus... So alpha I, alpha j, and alpha k was 50, 90, 70. 1597. If I add those up, and I think I'm going to use this as my strategy. So I'm ready to push enter. Let's not do that. 10 plus 90 plus 10 is 100, 105. 105 plus another 5 is 110. Add 2 is 112. So sweet, we have 112. All right, so we're going to do it one more way, and then we got to move on to something different. We can do a column, and this one's going to be easy because, hey, this is the 0 times the cofactor. And if this is 0, that number just goes away. So let's just kick this one out and show you that a vertical column works the same. All right, booyah. So we have the number 5. Is it positive or negative? Row 1, column 3. Okay, it's going to be positive. Next one's going to be negative, though. Keep that in mind. All right, so if I take out that row, that column, I'm going to have 3 times 1. 3 times 1 minus negative 2 times 9. See, now I'm just good, and I think I'm done. Took that number, cofactor is a positive, and then the determinant of those 3. 3 minus. And then let's see if I can do that in my head. So it's going to be 5 positive. This is going to be 3 minus a minus, 3 plus 18 is 21. 5 times 21, we already did that. It's 105. Booyah. So I'm going to store that as alpha I. Next one is going to be 7. And we already know this one better be 7, because we have to add to get up to there. But anyway, so we have 7 is our, the cofactor is a negative 1, because we have row 2, column 3. In this equation, 3 plus 2 is is 5. And so let's do that. So this is row 3, column 2. And that's associated with, and if I do this, so we have, row 2, column 3, it's that value. Your I is going to be 2. J is going to be 3. So we have A, so Aij is going to be A2, 3. When we do this negative thing, whether it's negative or positive, I'm going to go negative 1i plus j, which is negative 1, 2 plus 3, which is negative 1 to the 5. Now, anytime you get powers, and they're not huge, like, you know what I mean, like a mole of things, start doing this. Negative 1, negative 1, negative 1, negative 1, negative 1. Hey, we did that 5 times, and that's what that is. 2 of these is a positive 1. And now we have negative 1 times these 2 positive ones. So we're left with negative 1. Hell yeah. So that's the sign change. 7 minus the sign change, negative 1. This row and then this column. Cool. And then those are our 1 and 1. So we're 1 times 1 minus negative 2 times 1. And man, it's so easy to make mistakes here. So yeah, covering them up helps. 1 times 1 is 1, minus, this is going to be a positive 2. Alright, hell yeah. So we have 1 minus a positive 2. 1 minus 2 is negative 1. Hell yeah, I can deal with that. So that's going to be negative 1. We're going to multiply by 7. It's in a negative location. 7 times the negative 1 times that negative 1 is 7. Booyah. Oh, what the hell? Oh, see, I made my mistake. So there you go, first mistake, and that's why it's very useful to back your. If I just did this in my head, I messed up. You know what I mean? So let's go through it. So the value is 7. Its location is 2, 3. Okay, so it's going to be another negative. The cofactor is going to be a negative number. So I'm going to do negative 7. I can even write that down. Negative 7. And then the determinant, I'm taking out this row and this column, and I'm going to have 1 minus 2. So I probably wrote it in my calculator wrong. Yes, and that's so yeah, my calculator was wrong, because I have in my calculator 1 times 1 minus negative 2, and I didn't put that negative 1 right there. So that is 7, and we're good to go. Yeah, so that's interesting. I actually didn't make a mistake mentally, I made a mistake in my calculator. It's always good to have backups, let me tell you. Alright, so now that value was 7. We're going to store that as alpha j. Alpha k is 0. So we have alpha I, alpha j, and alpha k. Those are those values that we have to add. And we're adding the column values. And they add up to the determinant. Cool. And it's just useful because this equation shows that, hey, the inverse of this matrix is the 1 divided by the determinant. It's just a value. It's just a scalar value, 112. And the definition of it is if you had a cube, since this is a 3 by 3 matrix, if you had a cube and you applied and you multiplied those, points on a cube to this, with this matrices, the cube would change shape and its volume would increase by 112. So it's kind of interesting. Cool. And then the adjoint is just the cofactor, but the transpose. So that's even where this adjoint of A, I don't know, like that term sucks. But let's do it. So let's, fresh sheet. So we need the adjoint of A, which is just the cofactor. And then this is going to be the cofactor transposed. So now we have to do this for all the values, and let's try to get a little bit faster, a little crispier. And we know this is going to be our double check. This is the cofactor. This is the transpose. When you transpose things, the diagonals stay the same. Okay? And then everything just gets swapped from the diagonal. So this 5 goes to there, this negative 14 goes to there. That's one way to look at it visually. Sometimes I like to do that. Else, if I have this row goes to that column. The next row goes to the next column. This third row goes to the last column. Hell yeah. Alright, so now we can do a little busty. The cofactor is not now this value. That's where I got confused today and just made a simple error. Because like, hey, I'm doing the cofactor. Don't I take this 1 first? Hell no. No. The cofactor in its simplest, the cofactor of this value, which is A1, is just the minor of A1, multiplied by that negative positive thing. And that negative positive thing is just a negative 1, 1 plus 1. Now that's how I like to write it. Sometimes just pick a value and then be like, oh, I see it. The cofactor of any location, which would be an I and a j, is equal to the minor of that I and j location, multiplied by negative 1i plus j. So hell yeah. So that's going to be the formula we're going to be using. And, booyah. Okay, and then we're just going to try to kick this out because we have 9 values to do. We're going to make mistakes, but let's try to do this in our head. So it's not this 1. So I'm about to do that every single time. So the cofactor, just think positive, negative. I'm just trying to train myself. This is row 1, column 1. 1 plus 1 is 2. That's even. It's even. Now what's the minor of this location? Take out those. Anytime that I see a 0, I need to have like this red flag go on because it's so easy for me to be like 9 times 0 is 9. Like, well, for whatever reason, it's real easy for me to do that. And it's real easy for me to just say 9 times 0 is 0, and then therefore I don't have to do 0 minus 1 times 7. You know what I mean? So the determinant is 9 times 0. So 9 times 0 minus 1 times 7. And so 0 minus 1 times 7 is 0 minus 7. So hell yeah. So I'm going to say we have a negative 7. And it's these values. So the diagonals will match up, but it's these values I'm checking. Alright, moving on. And to do this in my calculator fast is just, hey, the location is 1 and 1. I'm going to have a positive 1, move on with life. 9 times 0 minus 1 times 7. But even right there, I was about to do 1 times 5. You know what I mean? It's real simple. If I'm crossing this row and column out and then doing this, it's really easy for me to do like 9 times 0, 1 times 5. I don't know. I just get a little bit... I don't think it's because I'm going fast. Probably I'm going too fast. Anyway, so that's going to be that negative 7. Moving on, we're going to have this value is row 2, column 2. That is going to be a negative 1. And this is where it gets, not the fact that this is negative 1, the cofactor, the location of that is negative 1. We're not using this value for nothing. Okay, hell yeah, cross out that row, that column. I'm going to say same thing, 0 minus a negative 14. 0 plus 14 is 14. 14 times negative 1 is negative 14. Booyah. And I move pretty fast there. So let's do 3 times 0 minus negative 2 times 5. And see, I did the same thing again. I crossed this one out, and I was just like, but I'm trying to figure out where I'm making mistakes, and I've already probably made 4 for this video. It's just really fast. The trickiest thing about linear algebra is, hey, I'm crossing this value out and that value out. The only 4 numbers that exist are these ones. It's really easy for me to do this and then that. Whew. So this is... let's bring that up again. So it's 3 times 0, negative 2 times 7. And that's going to be negative 14, and we have a check on reality. So I'm just saying for myself, it's really good for me to do it mentally and then the calculator. Sometimes calculator first, but don't push the button, and then mentally. So let's try calculator first and then don't push the button. So hell yeah, this value, what's the cofactor? Its location is 1, 3. That's positive. So positive 1. And then remove those. So I have a 3 times 1 minus, and then maybe I should do this again just to get visually. Negative 2 times 9. I think I'm good, but let's double check. So row 1, column 3. 1 plus 3 is positive. I'm going to block out these. I'm going to have a 3 minus a negative 18. 3 plus 18 is 21. And this was positive. 21. Booyah. Hell yeah. We did a little double check. So hell yeah, that's that value. When we transpose, those are those values. Alright, so I like that calculator first. Row 2, column 1, that's going to be negative. And then when I remove this, I was about to remove this and this, you know what I mean? This is just really interesting. And I should have better little sheets of paper. I do have some scissors. I mean, we don't have to make this rough. I mean, yeah, we can, hell yeah. Yeah, because if I'm trying to find the cofactor of this number, that's too much. But yeah, and part of this video is just like, hey, I'm trying to find the mistakes I would make and just stop friggin' making them. It's crazy. It is really difficult. I've actually kept track of all the mistakes that I've made. And I'll make other videos on that. It's kind of fascinating. I'm trying to look through my papers. I should just be focused. But anyway. Yeah, I actually write... On each paper I do this little whoop-de-doo so I can, and put it sideways, so I can go back to every mistake that I'm making and make separate videos on there. Alright, so the cofactor of this one is going to be negative 1 times 0 minus 1 times 5. And now I should just be money. Alright, so this value is row 1, column 2. We're going to have a negative 1. And when I block these out, 0 minus 5. That's going to be negative 5 plus that positive 5. So I'm just going to say final answer, positive 5. Sorry I didn't put that positive 21 in there. And yeah, we're good. And we're good. Okay, so this next one, row 2, column 2, it's even. And when I do this, I'm going to have a 0 minus negative 10. So I went fast there. I'm just trying to go fast and not make mistakes. So this value is going to be 2, 2. It's going to be positive. We can just totally ignore that part now. And the minor is the determinant of this. 0 minus negative 10. Minus a negative 10 is adding 10. So we should have 10. And we have 10. And that's that spot right in the middle. Next one, row 2, column 3, that is going to be odd. The cofactor, 3 plus 2 is an odd number. When we multiply negative 1 times 5, we get that odd number. Hell yeah. This and this is going to be 1 minus, looks like a positive 2. 1 minus positive 2. In my head, I was actually thinking 1 plus 2, and I said 1 minus a negative 2. No, I think we got that wrong. This is, see, I wrote in my calculator, this is 1 minus 2. And I should, so when I do my calculator, to make less errors, I should write it 100% crisp. So 3, 2, row 2, column 3, I always mess that up. This is row 2, column 3. That's going to be negative 1. And now the determinant is going to be 1 times 1. So do that. 1 times 1 minus. That's part of the determinant. Negative 2, negative 1. Just don't skip those negatives, and it'll come out to be the right answer. So now we can do it mentally, and then we'll do it with this. So we have a three-step check. Which one are we on? We're on this one. So we're going to have, it's in a negative location, negative 1. Let's see if I can remember that at the end. Take out this row, this column. 1 times 1 is 1, minus 2. 1 minus 2 is negative 1, and that negative 1. So we have 1. And if I did it this way, I definitely have a negative 1, due to that cofactor, but I have 1, or these two multiplied is 2, these two multiplied is 1. So 1 minus 2 is negative 1. And that cofactor location is negative. So I should have, so I checked it 3 different ways, and we have 1, and we can move on. Hell yeah. Alright, cool. The fast way, row 3, column 1, even. Minor is negative 1, 7. Negative 1 times 7 minus 9 times 5. Okay, now let's do it. Row 3, column 1 is even. Negative 7, I see that, minus 45. So it's going to be more negative. It's kind of like, we definitely have a negative. And this was positive, right? So yeah, definitely have a negative. 45 plus 5 is 50, plus the extra 2. So 45 plus 7 is 52. And we have a negative 52, because we have negative 7 minus 45. So negative 52. See, sometimes to do the mental math in my head, I have to get rid of the negatives and then bring them back in. But negative 52, if I did it, which one are we on? That one. Alright, we're back, and I forgot to put that value in for 1. We're on this location, and so it's a 3, 1. Row 3, column 1, so we just have a positive. And we're going to take the minor, which is the determinant of those 4 numbers. So this is called the minor of this 3 by 3 locate. At this value A, ij, which is A3, 1, row 3, column 1, the minor of A1, 3 is equal to the determinant of these numbers, a smaller matrix, and you could say this is A1, 2, A1, 3, A2, 2, A2, 3. It's really useful to be like, hey, row comes first. This is row 1, column 2, row 1, column 3, row 2, column 2, row 2, column 3. Try to spit those out as fast as possible, because those things, I don't know, they're really difficult to actually trust, because I transpose those all the time. Anyway, so hell yeah. So we had a positive value. The determinant's going to be negative 7 minus 45, negative 52. And that's what we get. Negative 52 for that value. And we got 2 more to do. We're going to have, this is row 3, column 2. We have an odd. We're going to block out those. We have 7 minus 15. That's a negative 8. Odd, it's 8. So I think this one's 8. We're going to use our calculator. 3, 2 is that negative 1. When we block these out, I'm going to have 1 times 7 minus 3 times 5. Not a lot of negatives, no negatives in this one except the cofactors. So just mentally I was able to do it way easier. I'm going to trust this one pretty good. So positive 8. 3, row 3, column 3, this is going to be odd. Whoa, why did I think this was odd? And why did I know this one was odd? And then, yeah, see, I'm messing this up. I'm thinking 3 times 3. So when it comes to linear algebra, I'll see 3 plus 3 and think it's 3 times 3, just because linear algebra is constant addition of values and constant multiplication of it. You're always adding and multiplying at the same rate. So I will see these and say they're both 9, or, you know what I mean. And so that's crazy. And so I just thought row 3, column 3 was odd because of that. Because it just seems like, oh, it's a 3 by 3. You know, 3 by 3 matrix, maybe that's 9. But for this, I plus j is that part of the cofactor. That determines 3 plus 3 is even 6. It's just an odd plus an odd. Maybe it's odd. Anyway, it's not. So hell yeah. So we're going to, that's why this last one was a negative. Row 3, column 2 is 5. A cofactor, the sign on the cofactor is going to be negative. And the cofactor is just the minor plus the sign part. So it's the juice of the cofactor part is this. It's just taking the minor times that sign change. That is it. That's kind of weird. So even though it has its own little, it's not just minor positive, you know what I mean? They have a separate term for it called cofactor. Whatever. Hell yeah. So this is going to be an even location. Row, column. I'm going to have 9 minus a negative. So it's going to be 9 plus 3 is 12. Hell yeah. I would have to double check that one. We have a positive location. We have 1 times 9 minus 3 times negative 1. So just interesting. Even when I do it, like, I just have no way of knowing if I'm confident. Because when you do make a mistake, you are just as confident making that mistake. It is bizarre. But hell yeah, we got a positive 12, and we did it. Hell yeah. And all we have to do is take this cofactor and do the cofactor transpose. And the way I like to do it is take this first row, and then make it go this row, make it go down into this column. Second row, make it go down the next column. Third row, make it go down the third column. So that's the transpose, and we did it. You know what I mean? Basically, I shouldn't stop here because the whole idea was no. This is going to be part 1 because I said we were going to do 9 equations, 9 unknowns in a different way, but this video is long enough. This will be part 1. The second will be solving this without using this catchy method. This catchy method is rotten proof. I shouldn't say that word anymore. You know, words can be used 3 times and then no more. Anyway, so yes, there is a proof behind this, and in that proof, I think how should I say this? A lot of, like me, I need something needs to be visual for me to understand it. If the numbers just make sense, I'm not just like, oh, the light bulb for sure went on. So even the proofs of some of these linear algebra things are just like, sure, man, you just give me the equation. And this is one of those places. I'll dive into the proof, but I can't follow it yet to be like, oh, hell yeah, it makes 100% sense. And just the sense would be like, cool, what we just did, transpose it, and then multiply, and then divide by the determinant. Whoa, like obviously that's the inverse. You know what I mean? There's no way that couldn't be the inverse. That's what like knowing the proofs should scream at you. If you don't know them, then you're just like, oh, this is bizarre. To find the inverse matrix, I do 1 divided by the determinant of A times the transpose of the cofactor. So that's what we have. So the inverse of this matrix is this cofactor multiplied by 1 divided by the determinant of A, which is 1 divided by 112. So this multiplied by that is equal to the inverse matrix. So those are. So we're just going to double check this, and then we'll finish the video. So hell yeah. And that's what we got. We got our transpose of the cofactor matrix. And then all we have to do is just multiply it by 1 divided by 112. And we got the inverse of that matrix. We just need to double check. And this is how matrix are multiplied. So if I have A multiplied by the inverse of A, I'm going to have... And any scalars can be done, it's kind of like integration. I can do those absolutely later. Or scalars don't conflict with the internal multiplication operations. You know what I mean? When you multiply two matrices together, if you factor out scalars out of both matrices, you can put them to the side. So that's what I'm going to do. I'm going to say this is 1 divided by 112. And, I mean, if I wrote this right, this would be A times cofactor transposed. I mean, can't you see that? You know what I mean? So that's kind of what we're doing. And, not to be too confusing, but we're going to multiply these two matrices. So this row multiplies by this column. Now, I started the video, before this video, I kind of started it, and I talked about this. Is like, hey, when I look at a matrix, especially this first one, what I notice the most is that I have 3 rows, and I don't need all those rows if I didn't want all those rows. You know what I mean? Hey, if I just had one of those rows, I'd still just be chill. You know what I mean? Nothing, like I could, if these two multiplied, cool, I could still multiply this one by that one. You know, so that's the first thing, that's the first light bulb moment I had with matrices, just to have some sort of ideas, just like, hell yeah. Sure, you have a lot of rows, you don't need them. You know what I mean? You could have just had one row maybe. And then you could start multiplying. And we're going to show that in a second. And then over here, I only need one column, because this one row has 3 different things going on. When I multiply matrices, I have to multiply this by something, and then I have to multiply this by something else, and then I have to multiply this by something else, and then add those all together. So if I made a mistake, I could be like, well, don't I just multiply, this by that, and this by that? No. You know what I mean? No. And this is just by, you could have, if they set up matrices this way, it could have been that way, but they chose, I forget the word of like, hey, let's pick a system and stick with it, but they chose to do it this way. So over in this column, I didn't need 3 columns. These 2 columns are like extra, you know what I mean? I could have just multiplied this matrix by that matrix. And when I do that, this has something to multiply, 1 times -7. This value has something to multiply, -1 times -14, and 5 times 21. My brother says that to this day, even when he's multiplying, he takes one finger here and one finger here, goes down this column as he's going over this row. So he goes here, here, here. So this is, you know what I mean, it's what I do too, because I trust my brother. So had we just multiplied this one row times this one column, we only get one value, because 1 times -7 plus -1 times -14 plus 5 times 21 is just one value. You know what I mean? And so if I did multiply those, they would just go into that upper value. So this row times this column gets placed in that first row and first column. So that's the output. So when we have a 3 by 3, let's just get to it. We're going to have an output of 3 by 3, because let's say we just had one row and 3 columns. Cool. You're going to get 3 values, and they're going to, if you have one row here, your output is still just going to be one row, but you're going to have 3 columns of numbers. And if we have 2 rows multiplied by this, you're going to have 2 rows and then 3 columns of number. We have 3 rows, 3 columns. So that probably, I don't know, you know what I mean? Probably still confusing as hell, but hell yeah. So we're just shooting for this value right there by doing this. So this row and this column makes that value. So we have Negative 1 times 7. I'm sorry, 1 times negative 7. Sorry, 1 times negative 7. Well, let's do this down here. So we have 1, negative 7, plus negative 1, negative 14, plus, so this is really difficult to do in your head, 5 times 21. 5 times 21 is 105. This is going to be 14, and this is going to be minus 7. These two are going to be plus 7 plus 105. That's going to be 112. So we have 112 divided by 112. And guess what we get? We get 1. And the other thing that we're doing here is, what the hell are we even checking? Well, a matrix times its inverse is equal to the identity matrix. And hell yeah. And this is the part of the video where I'm just like, well, you know what I mean? I'm tired. I don't want to explain no more. But hell yeah. It's just, let's see. Here's your general, and that's the wild thing about matrix. This X is a vector of a lot of, this is X1, X2, X3, X2, and X to Xn. It could be forever, you know what I mean? And then this is, so AXB. This is a matrix. This is a matrix. You know what I mean? So this, we're used to having like 5x is equal to 10. And, well, this would be 5x to the 1 is equal to 10. Where a matrix is like, well, what if I had 6x to the 2 is equal to 12. You know what I mean? And so forth. And I had x3 was something different. And so, hell yeah. And then I wanted to know if there was, what do I want to know? Oh yeah. That was horrendous. And that's not, I mean, honestly, this X should be thought of for, if you're just getting into it, it should almost be thought of X, Y, Z, W, and, you know, pick letters after that you want. Because that would be the same as saying 5x is equal to 10, and then 6y is equal to, well, let's just do 3. But sure, like obviously you can pick a y value that makes sense and an x value makes sense. With matrices, what you're going to have is 5x plus 2y is equal to 10, and then 6y minus 2x is equal to 3. I shouldn't have wrote it that way, but then you'd have to put it in matrix form, so you would have 5, negative 2, 2, and 6. You would have xy, which is just your, you know, boldface x for your vector with those coordinates. And then you have b, your output, which is 3, 10. And you're looking for the x value and y value that satisfies. But even when we have a 3-pack, you're going to, and we can probably start to do this just to see, like, why does this make sense? If I have 3x plus 2y minus 3z, and then I have 1x minus 5y plus 10z, and we got to add equals 7 equals 4, 2x minus 10y plus 15z is equal to 5. Not only could there not be a solution that actually you pick a x, y, and z that makes this make sense, you know, then if there is a solution, like, hey, what's the answer to it? Well, it's not the most difficult thing in the world. Yeah. Not the most difficult thing. Yeah, 3x3 matrix, aren't they right on the edge of being like, well, I could have done it myself? Oh yeah, and I'm so glad I'm doing this, because you do the textbook, this stuff comes up all the time, and it's like you have to, like, yeah, if I did this, I could solve this. I could just solve this equation as x, and then shove that x into this x, and then have y and z, solve for y, shove that y is equal to z. and this x into that, you know what I mean? You do that a couple times and you get an equation where you get to solve for z. If you solve for z, you solve for y, solve for x. So you can, that's the Gaussian elimination, or it's just go for it. You got 3 equations, 3 unknowns. You know what I mean? Do it engineering style. Which is just, no one taught me matrix algebra, which is a shame, but not really, because this stuff is, if you're just doing 3 equations, 3 unknowns, I think matrix algebra is going to cause you more mistakes. You'd for sure have to double check. I've made more mistakes doing matrix algebra than any other process on earth, and I've caught more mistakes in this book where it's just like, oh man, you just messed up because you just have so much number manipulation that is nonsensical, just in the sense that it's meaningless, or it's really hard to, have the meaning. So then it's just messing up. Sign changes, a lot of ways to mess up. So yeah, so the textbook reason of why you want to find this, it's not to solve this equation. This one I don't care about, but check this out. What if I change these values to 10, 2, and then 3? You know what I mean? Am I going to have to go through that entire process again? You know what I mean? Solve 3 equations, 3 unknowns. Let's say I change them again. 5, 3, 2. And then not only will I have to go through that entire process again, maybe this doesn't have a solution. I'm not going to get into whether this has a solution or not, because they haven't taught me that yet. But I think if the determinant, don't quote me on this, but the determinant is not 0. If the determinant of that matrix is an actual number, I think you have a solution. If it's not, and it's so fascinating because those things will get proven in the proofs, where it's just like, if you look at what they're doing to the numbers, you'd be like, oh, now I see it can't have a solution. You know what I mean? And so I do look forward to learning the proofs, but the first go around, it would take an absolute G to write it in a way for, the general public to be like, oh, I get what you're saying. Anyway, so hell yeah. So what we want, so this equation right here is a 3, 2, negative 3, 1, negative 5, 10, 2, negative 10, 15 matrix with x, y, z, which is your a, x, and then we have a solution. And I can just choose whatever numbers I want for a solution. And like I said, I want to choose different ones at different times. So that's my solution set. And then I want to find the values that make these equations jive. So a lot of physics, hell yeah, you'll know these outputs, and then these equations. You'll have 3 equations, 3 unknowns, and you're trying to solve for those unknowns. And then you want to change parameters. So the general gist is, hey, can we just get this all by itself? And yes, you can if you take the inverse matrix to the other side. If you multiply both sides by the inverse matrix, hell yeah, you get this inverse matrix B. And then don't quote me on this, but I think with multiplying matrices, yeah, I think you have to do it. Well, obviously, this should spell itself out. Inverse of A has to be multiplied by that, because if this is a 3 by 3, we have 3 rows. Like I said, I only need 1 row, and this B is a solution set like that. So this makes sense. So that's how I do my double checks. Is like, is it this way, or is it this way, or does it matter? Because this would be a 1 by 3, which, you know what I mean? I'd use that strategy of just like, cool, I have 3 rows of 1. I could have just had 1 row of 1. But then when I multiply it by 3 columns, and a lot is going on with this one. Well, I can multiply it by 1 column as long as that 1 column only has 1 thing in it. I could multiply it by 2 columns, but that 1 column only has to have 1 thing in it. So I could multiply this 1 value by that, but get out of town, because this is saying like 1. Like, this is just like x, not, this is 1 value times x, not 1 value times y plus 1 value times z. This is your x, y, z values that you're multiplying. Anyway, alright, hell yeah, that was pretty loose, and my camera is about ready to juice out. That sucks, man. Let me get some more juice. Alright, hell yeah, I only got 2 minutes of juice, so I either have to go get more juice out of this SD card or switch cards or do something. So, but this kind of brings us back of, I don't want to explain this identity, but if we do have this AX is equal to B, and then I multiply both sides by the same thing, then what happens is this has to cancel out, and it has to just equal kind of a value of 1. And then that's just kind of like 1 times this x is equal to inverse. So that's kind of what it means. And so that's that double check that we're doing. And we're just saying, hey, if this is the inverse, then this value should be 1, 1, 1, and these values should be 0. So I guess I'm going to throw in another SD card, and we'll just check all these values to make sure, hey, this row and this column has to equal 0. And so, if it's 0, 0 divided by 112 still has to be 0, so that's cool. So, like, these values have to be a multiple of 112 if they're going to be something, anyway, so yeah. So this one's going to be 5 minus 10, that's negative 5, plus 5 is 0. This one's going to be negative 52, negative 8, that's going to be negative 60. Plus 5 times 12 is 60. Hell yeah. So those are pretty easy. This row and this column is that value. Negative 21. Don't know it. Big numbers. Alright, let's get a SD card. Well, yeah, holy hell. So negative 21 minus another big number. So negative 21 minus 90 is negative 101. Minus 36 is probably going to be 137. That sucked. And then 7 times 21 is 140. Alright, hell yeah. We were pretty close, but I think I got this. I haven't done any double checks. We got 21 seconds. So we have negative 21. So negative 20 minus 90 is, that's negative 110, plus the extra 1, or minus a 1. 100. Alright, hell yeah. I'm not giving up on this. So, how would you do mental math in your head? I'm trying to multiply these rows together and figuring out what the value is. I'm going to have negative 21. I'm just thinking negative 20 is an easier number to memorize. Then I have minus 9 times 114. I'm going to say that's 9 times negative 10 plus 9 times negative 4. So 9 times 10 is 90. I could say it's 100 plus the 21, that goes down to 10. You know what I mean? It's 11. Well, let's just get that all the way through. Negative 90 minus 21 is going to be, I have a real hard time with that one, but it's negative 111. It's just because the, 21, 22, 31, 32, but the 11s suck. Like anything in the 11s, that's another like, hey, you're going to make mistakes. Alright, but, so we have negative 21 minus 90 is the same thing as negative 11 minus 100. That's really difficult for me to do mentally, but negative 111. Hell yeah. Now we have to add another 36. No, subtract another 36. So that's like a negative 11. Negative 111 is very similar to negative 110. Minus 36 would be negative 137. So that's where the negatives always mess me up. It's just mentally it takes up just a little bit more space in my brain. And if I can just get rid of that negative. So hell yeah. And then we'll just have that minus 1 that we... So we have negative 137 final answer. That's what this better equal. 9 times 21 better equal positive 137. 9 times 2 is 18. So we have 180. No, what the hell? I'm messing this up. So, yes, row and column. This, and this. So that's another place where I just got, my finger got stuck on that. So hell yeah. 7 times 21. 7 times 2 is 14. Add a 0 is 140. Plus another 7, 147. Why are we off by a little bit? Okay, back to the drawing board. I'm going to dig my heels in on this one because mental math should not be. It is hard. It's really hard for me because it's like juggling. Negative 21 minus 90. That's going to be negative 111. Here's where I'm making my mistake. Subtracting another 36 is negative 147. Yes. So we have negative 147. I really don't want to write it down. It's really hard for me to visualize it. It's a very odd number. Negative and then 147. So cool. 7 times 21 is 140. Because 7 times 20 is 140. Because 7 times 2 is 14. Add a 0 is 140. Plus 7, 147. Hell yeah, that took forever. But yes, negative 147 plus 147 is this 0. Cool. Moving on. Alright, checking the next one is going to be this row in this column. So we have 15 plus 90 is 105. Plus, am I messing up again? What the hell? 15 plus 90 is 105. Uh-oh. What? No. Yeah, see, why am I did that. See, with my fingers, I did this, and then I did this. It's just the fact that it's really hard to, like, rub your belly and pat your head. So yeah, this video, I'm very satisfied with, because linear algebra has all these mistakes that you're going to make that are just Looney Tunes, man. And it's like, and you're not even going to know about them. You're not going to know why you're going to make those mistakes. So I think one way, because your brain is going to get hijacked when you have to think about something, is I think for me it's like do this. It's like, okay, this row, this column, what value is that going to be? It's going to be the middle value. Cool. Then I'm going to do this. Cool. Then what I look for is negatives and zeros and ones. You know what I mean? So like, hey, I see a 1, cool, but negatives for sure and zeros. Cool. So I even do the easiest stuff first. The last one's just going to be a value of 7. Cool. And then we have 15, 90, and 7. So there you go. So 15 and 90 is 105, plus 107 is 112, divided by 112. But yeah, even that one I made a little mistake. So let's go to the hard one. The last hard one is going to, we'll keep that one for the end. So this row, this column, is going to be that value. And we have negatives. So we have 2 negatives. Yes, so this is what I'm looking for. If I see negatives, hold the phone. I see zeros, hold the phone. So the last value I can get rid of, make my life easier. The middle value is a 1, so it's just going to be a negative 14. These values are negative, so it's positive. So the only negative on here is negative 14. But see how many places you could make little errors? So we basically have negative 14 plus a positive number, which is 14, so that's 0. So see how that really simplified to be like last one goes away. This one's negative 14 for sure. These two are going to be positive. Positive 14 plus negative 14 is 0. All right, let's do it for the next one. This row, this column, is going to be that value. So I'm going to do this. See, this 0 can trip me up, because maybe I just use it as a 1. So that goes away. This one's a 1, and even ones were tripping me up. So this is just its value. 1 times 10 is just its value, and then here's a negative. So I have a negative, just a value, and then the last one goes away. So I have a negative 10 plus 10 is 0. All right, hell yeah. All right, last one, and we can finish this video. This will be part 1, and then we're going to do it 9 equations, 9 unknowns. How hard could it be? It's incredibly hard. All right. last one. This row, this column, that's this, it's got to equal 1. So this, I see a 0, blocking that out. I see a 1, it's just that value 8. I see negatives. There's 2 of them, they're going to be positive. So I'm going to have these be multiplied in positive, plus an 8, plus a 0. So cool, I'm just going to have this, positive this, plus 8. This is going to be 100. Oh, don't mess this up. 2 times 50 is 100. And then 2 times 4 is 4. So this is 104. Why did I get confused that the other one was like 105? Because it was 5 times what? It was 5 times 21? Yeah, I think it was 5. 5 times 21 is getting me confused with 2 times 51. Those came up in this problem. 5 times 51 is for sure 105. 2 times 51, totally different, and it's even, and it's going to be 104. 104 plus 8 is 112. A positive 112 divided by 112, and we have that last value. So yes, if this is A, and if I multiplied by the inverse, I would have the unity vector. And so now I guess I will go the extra mile of what does this unity vector means? Well, if I have this vector and I multiply by this vector A, I will get vector A. I will get itself. So let's do that and then we'll be done. So this is vector A. I'm going to multiply it by these and I should get vector A again. So we're going to do this row, this column. So 1. So let's just do that. Let's do all the tricks. Hey, I see, because the zeros are the most important. 0, 0, I see zeros. This is where I'm going to make mistakes and just be like, oh, I don't see these zeros. So when I multiply these, it's -2, and then no, so these are zeros, they don't count, and then we have 1 times 1 is 1. Row and column is going to be this next value right there. Let's do that same thing. Okay, I see some zeros. These don't count. And so I have 1 times -1 is -1. And we'll see a pattern. Okay, so we have row and column. Do the check on zeros. Ooh, I see a 0 there. I see 2 zeros there. Hell yeah, so these are all zeros. 1 times 5 is 5. We'll try to do this all the way through because it's very interesting. And you're just going to get the same matrix. Row and column. I see a 0, I see a 0. So those 2 columns have 0, and it's just this value 3. And it's going to be row and column, so it's going to be in that location, same as this matrix. All right, row and the middle column is going to be this value right there. This is how I'm going to be doing the multiplication and addition. This is 0 and this is 0, so the only value is just this 9. It'll go right in the middle. All right, speed up the process. Row, column is going to be this final value. Second row, third column. All right, 2 zeros are part of those, so it's just this value 7. And then it's the same thing on repeat. So we have row and column. The most important thing is like, where does this value go? Row and first column goes into this row, first column, right there. 0, 0, so it's just that value -2. Right there, row and column goes into that third row, second column. 0, 0 is just this value 1. And then for this last one, look at this. You might make a mistake. Where are my zeros at? Hey, 0, 0, 0, everything's 0, so we have that 0. Hell yeah. Alright, so we're done with this video. That was part 1, going through the inverse matrix process. And in the next video, part 2, we're going to do the 9 equations, 9 unknowns. Like, how hard could it be? But I answered my own question because, sure, no. Like, no, finding the inverse matrix from 9 equations, 9 unknowns still gives you this, and it's still useful. I can use this inverse to solve any, values. We said that I can throw any value of b in there as long as my setup. So if I have physics problems that are like, hey, this is this, but then this part of the equation can change, and I can modify that or tweak it, then I have a solution. This inverse matrix can be an easy solution. And the name of the game is just computational time. Sure, if you can start from point A and get to the answer in some sort of computations, go for it. But what if it takes you all day to do one computation, and then I just changed one of these numbers, and you're just like, well, I have to spend all day doing that again, compared to just having something that you can just, use to find multiple solutions, if you change these parameters. So that's one concrete way that I can be like, hell yeah, it could be useful to find this matrix, because then it'll be useful. If it's just my physics problems, or 2 equations, 2 unknowns, 3 equations, 3 unknowns, it's not going to be useful. So that is where, physics books are set up to introduce you to the integral calculus and differential calculus while they teach you. There is absolutely no reason why physics problems can't just have 5 equations, 5 unknowns, and then say, really the only normal way to solve this is with matrix methods or linear algebra. That is the same thing as them giving you equations or giving you physics problems that require you to use integration. You know what I mean? So it's just fascinating that even the textbook's problems are kind of cookie cut to lead you down these specific routes. Even the integration problems, you can still solve them from, the birth of integration. You can just, make small slices and start summing. Make a guess and make better guesses. That's basically integration. That's what I like about problems. Was just like, I don't want to solve it in the way they want me to solve it. And so that's why we're doing this. This was the legit way to get that, but now we're just be like, how hard could it be to set this up and find this? And it kind of shows you, a visual process of finding this inverse matrix, but not really. Still, it gets down to the place where it's just like, well, what did I do here? I multiplied this matrix times the inverse, and I got the value 1. I did this, one of these columns, one of these rows, one of these columns, to get this value 1, to get that value 1, to get the value 0. And I did that 9 times. Those were 9 different equations. And sure, I had this I already knew this, but if I didn't know this, I would have 9 equations and 9 unknowns. So that's going to be part 2. Hell yeah, thanks for joining me, and that's a video.